All right, problem 3-106. Lexington High School has an annual growth rate of 4.7%. 3 years ago, there were 1,500 students at the school. Letter A, how many students are there now? I'm wearing out, so I'm going to work through this problem there, get you through to the answer. I will continue to explain, but I'm not going to go in as much detail. So if you need to ask your teacher questions, if something doesn't make sense, I would definitely recommend that to you. Since we're growing at an annual growth rate of 4.7%, we're not going up at a constant rate where we have the same number of kids each year. We're growing by a percentage, so this is exponential growth. So we're looking at using an exponential function, y equals a times b to the power of x, where a is our starting value and b is our multiplier. Well, if we know that 3 years ago there were 1,500 students at the school, I'm going to kind of treat that as my starting point here. So I'm going to say at 0 years, x being the number of years since our starting point, and we don't know exactly what year that is, but I'm just using 0 to signify that's where we're starting time. So x is going to represent years, number of years. Y represents our student population, so I'm going to put 1,500 in as my population there. Well, we already know that 1,500 was the starting value for our students. Our multiplier is going to come somewhere from this. It's growing at a rate of 4.7%. So what you have to remember about a multiplier, you always want to start your multiplier as 1, because when you multiply something times 1, the value does not change. And remember that 1 is the same thing there as 100%. So if I multiply something times 1, I don't gain anything, I don't lose anything. So I'm actually going to put 1.000 here. So if we started out with our multiplier, and remember this is the multiplier, this is just what it is as a percent over on the left. Multiplier being 1, we wouldn't change. It tells us that we are growing by 4.7% each year. So I know that each year I'm going to add 4.7% to my 100%, which should give me 104.7%. And if we look at each of those as decimal values, 4.7% is the same thing as 0.047. And we add that to our 100% that we had. We get 1.047 as our multiplier. That should make sense. We're growing each year 4.7%. So it's not a lot of growth, but it's growing. So our value should be greater than 1, but not a lot greater than 1. Let's use what we know here and plug them into our equation. We know that y equals a, which is 1,500 students, times 1.047. That's more or less 104.7% over X number of years. So letter A was asking us, how many students are there now? Well, remember this information we were given, we said, okay, 0 years, we were at 1,500 students. So 3 years later, 1, 2, 3, we're trying to figure out what our population is. So let's input x into our equation, into our function here, and figure out what our output would be. So y equals 1,500 times 1.047 raised to the third power, because we're 3 years later. You can go ahead and type that into your calculator. Make sure you're careful when you do it there. And you should end up with the value 1,721.4 596 dot 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 there. We're talking about the number of students, so we're not going to include a decimal as our answer. Let's go ahead and round it to the nearest student, which would be 1,722 students now. Now let's go here and actually how many students are there now? There's 1,722 students. And then it says, what about 5 years ago? Well, I'm using a table and the values that I'm using for X represent the number of years since that year where we had 1,500 students. So that was 3 years ago. In order for me to come up with an input value that was 5 years ago, I need to go back 2 more. So this is back 1 year, 2 years, 3 years, 4 years, 5 years. So my input value into my function, this is 5 years ago. I'm going to substitute that in for X and solve it. So I have Y equals 1,500 times 1.047 to the negative second power. When I compute that there, the answer I get, and I'm just rounding to the nearest person here, it should be 1,368 students. Remember, we can't have partial students there. So it's 1,000, oops, not down there. That was the wrong location. Just fix that there. We should have 1,368 students. I guess I could fill in my table a little bit here. I knew that this one was 1,368 right here. This one is 1,722. Now part C says, how many students will there be n years from now? And this one's tricky. And there are several approaches you can take. If we want to go ahead and continue using the same equation that we've already started using, and to me that would probably be easiest. If we're talking about n years from now, remember now we were at 3. So if we take our equation that we already used to come up with our value for what our population currently is, we said 1,500 students times 1.047 to the third power. This represents the number of students we have now. If I want to know n years from now, I'm going to probably want to take it then, and I'm going to add in plus n in my exponent. If I wanted to know, 2 years from now, well, how many 2 years from now? I would go 4, 5. I would want my exponent there to be a 5 using this equation. So I would take value of 2 years for n, 3 plus 2 would give me my 5. So this equation here should work if you're using 1,500 as your starting point. If you want to set it up, some of you may think about it from our population, from what it is right now. Another possibility you could come up with is saying our population right now is 1,722, and it's going to be growing by the same growth rate, which is 104.7%. So our multiplier is 1.047. And we could raise that to the nth power. And that would just be n equals number of years from now. And either one of them there. So either one of these equations would work. It just depends on if you view it as you wanting to start with the population that we're currently at, or if you want to continue using the same equation that you already used for the previous part of it. Hope this helps there. If you have questions, make sure you ask your teacher. Good luck and keep working hard.